Good morning, good afternoon, good evening, everyone. Topic of ML powered, machine learning powered IoT, Internet of Things, from warehouse data to production intelligence in real time elevator pitch. So, first of all, let me introduce myself. I'm Dinesh Kumar Garg, working for Honeywell Integrated, and I work as a senior IT manager in the supply chain management. So, I'm a digital supply chain IT man. So, let's go back to the start, get on the topic. So my cursor is a little finicky, so I'm hoping it will work fine. So real challenge comes up is that today most industries does have the data is a lot more collected. But what now, since data is there in stored in most of the ERP systems, most of the machine learning system, most of the databases, what next? Beyond data collections, what's the real challenge? So modern warehouses generate multiple terabytes or gigabytes of the operational data, and basically every transaction when you do it, it requires like a load of data. So every assume that if you do a inventory transactions, so it stores like at least 4 to 5 record in the database, and that means all those records doesn't mean anything unless we really somebody needs to analyze it and figure out what really needs to be happening now. That's why the our statement is raw data doesn't equal actionable intelligence. Raw data doesn't mean anything unless we somebody make a mean out of it. So we are right now looking at a lot more doing in the machine learnings. A lot of studies are doing in AI. Last 3 4 years, there is a lot of AI and machine learnings are coming up. But if you really think about, say, most of these AI and ML projects are really still not live in the industry because they are just still theoretical. Most of them are still not really far away from the industry. So if you see about say some of the examples, like we do have the noisy sensors, equipment is failing, evolving the conditions, all the stuffs are really the examples of the some of these like data failures or accuracy failures in operations. And now I'm just going to talk about it. How do we really think about it in terms of the ML, and how do we AI and ML can help out in the down the line? Okay. Next one is why traditional machine learning approaches fails in production. That's a good question. So traditional machine learning generally fails in the production. We need to be there are generally three reasons. One is the data quality issues. Since there's a lot of data in the systems today, but still we do not have the data what we need. And methods are today they are still getting out away from the exact methodology, but still they are still far away. Second one is integration challenges. So everyone who's working in industry knows about integrations. So integrations are the heart of the industries. So assume that say for any data we capture from the shop floor, your like any devices, any sensors, everything requires the integration to the databases. Now you can argue about say, hey, why do we need databases? We're still in the world of the static databases. All the data is still lying behind there. And of course, there's a third point is performance degradations. So after say over time, there is a too much data, too much scenarios, and humans are getting a lot more intelligence. That means those performance is degrading over on time. So let's go a little bit deeper on the data quality issues. So data quality issues means sensors failed out or data is drifting. I recently wrote an article on the inventory drifting. So I'm assuming that it's very similar out. Say, if you're talking about, say, I do have the shop floor does have the 10 pieces and I in actually may have the 8 pieces. So data is actually drifting from the equipment aging. Network is a big things. And of course, environment interferences, right? So somewhere, say, or most of these computers or sensors sometimes just fail out. I've seen our industries where we do have the robotics and things like robots are trying to record all the transactions, and suddenly like some kind of like a heat wave comes up, and then all those one transactions were failed out. Integration challenges, if you most of them are aware of, say, APIs, everything is trying to be, um, this is world of APIs. REST APIs are a lot more common. So how do we really, how do we connect the two systems with the REST APIs? And most product will claim that, hey, they are REST API compatible. But in reality, most cases like REST APIs are not really compatible. Latency, big gaps is we are moving into the cloud, And that means if you're talking about the everything is moving cloud, not on-prem, they intend to be latency. Internet is really moving speeds, but still we will have the latency mismatch between the components. Synchronization issues, it is similar to integration, I will say, and of course error handlings. Now on the third topic of the performance degradation, if you talk about the scenarios are as a moving for so many, and of course, the remaining things are, I will say that model drips and current productions, they are like human behavior as well as system behaviors. Quickly moving to the topic is talking about the from the raw Internet of Things data, raw IoT data to the ML features. So if you talk about, say, how do we really get into the machine learning features where we can really use the production. So if you see about on those one, right, there are like say four techniques that are mentioned out here, but honestly there could be like maybe way more than that. So I will really think about say like simple examples on the first technique is say the rolling windows. Rolling windows means if you talk about the lead times in the industry, which is still static. So I will say that hey, why not like instead of making a static lead times, why not making our lot more rolling windows? And of course, we need to be tracking our say times since the event tracking. So I recently wrote an article on the time-based lead times, to be honest, or time-based cycle counting of physical inventory. That means what will happen there is that hey, I started my counting of the parts, and since the last time I counted parts was the current counting there. And if I'm doing a adjustment in systems, can I take a like a detects of both the events and say find out hey, I can do an anomaly detection. Hey, normally I do 10 pieces of manufacturing or backflush. Can I do it like 8 pieces? This time I did the only one piece. So something really happened. Either demand dropped so badly or supply increased too badly. So that's where the anomaly detection really help out in the machine learnings. Time series imputations. Basically, this is more of a standard forecasting methodology I will normally call as. So even most of the ML models are really getting on the time series as well. So it's pretty helpful, but still, I think it needs to be really used very carefully. It may be useful in defining out the missing data so that in terms of, say, I do have the demand is missing for the period number three, how can I still find the demand for that one without doing out, without asking out, without guessing it out? Even still, I've seen in the industry a lot of planners still guess the data. Then, of course, edge computing, which means, of course, we need to increase our power and so that we do have the latency is pretty low and then we can see the real-time data. And of course, that's a pretty really story of pre-element production, handling the messiness, missing data and census failures. Of course, every day we see out a data is missed out in the industry. When I see about it, every month my support team comes up and they tell me that hey, we do have the 10,000 transactions failed, and they say why. They say one of my interface failed out or one of the sensors failed on the production line, which then didn't record the data properly. And then it comes up like, say, what shall we do? Fill the spreadsheets on these production floors. They are still, the network is really messy. So it is going to be happening out. So there are three techniques which normally will be helpful. I'm still not very confident that it is still we are still there, but we will be at point of time will be there. One is time series awareness imputation, second is multi-sensor fusion, and third is metadata features. Time series awareness means if there is a data missed out, at least we can make it somewhat guess and somewhat real more informed decisions. We can at least do have some context. And of course, instead of the one sensor, can we do it multiple sensors? Or can we do that? It requires a lot of cost as well. So that means the cost will increase. And then of course, metadata features. So metadata features will tell out, say, which signals are there, or in terms of the metadata, how do we really find out, say, this transaction does have the four types of metadata. Can we really break down? Can we really do an informed decision at all? So that will actually help us analyze the patterns of the signals as well as equipment health issues as well. Let's move on to the next one. Next one is machine learning operator ops architecture for production. So this is pretty interesting that so we need to be really looking at revamping the productions. So basically we need to be creating the systems that will actually work at scale. Current machine learning algorithms are pretty theoretical. They are still evolving, but they are not at a scale that production can be using it out. We are, I will say, at least like few years behind it. So in this cases, if you say there are three technologies, we're talking about containerization and model serving, and second one is model versioning and deployment, and third one is continuous monitoring. So let's think about what each means. Containerization and model serving means, have you heard about the microservices? So microservices architecture is pretty small. It's pretty lean architecture. That means we are also using our NoSQL kind of concepts. NoSQL means databases are pretty lean. They do not store the static things. They are like, say, pretty much storing only the metadata. And that means what happens there is production doesn't need out like a big core, big APIs. And also in that cases, latency becomes really reduced because we can do the similar research using the one of the AI or vector DB methodology where you can simple example is how instead of doing the static matches, why not use the cosine similarity distances? So in that cases, you can do the fast latency and you can do the high service availability. It may not be exact, but if you think about like say, once at the end of the day, it may not, most of the production data, as long as it is 80-90% accurate, we will be good enough. Since even in the today's production one, we are seeing so much loss, we hardly get like 50-60%. But even if we this apply this and if it gives my 80%, 90%, 95%, most like the microservice architecture and vector DBs normally are not looking for exact matches, since exact matches means you will have the high latency. And of course, horizontal scaling of traffic skypes will always try to be plot the graphs, and you can just learn how the like this traditional methodology, the quality in production is used as scatter plotting, for example, or say fishbone diagrams. People can like quality can do it all those diagrams still, and they can look at like, hey, where's the scale, where's the really the anomalies are there, and they can actually do it. So that is called the containerization. Even the most of the databases currently are coming up as like they are containerized databases for the sake of so that we can be really sustainable as well as the architecture is pretty smooth. And of course, there's a second methodology we talk about the model versioning and deployment. I will say this one is more of say not for the production, but it's again the technologies are going. So that means we are looking for say a lot more like metadata tracking. We do have the lot more versions. Like instead of having the single version, we can have like multiple versions, and so that if we need it out, say if, if something went wrong, we can always go back. Like a sensor failed on the floor, can we really go back to the old version real quick? Like version could be like as fast as like a couple of minutes back. So what that will means that you're not dependent on say something got failed on the production. You don't need to rebuild it, recompile it. All you just do is just simply go back and redeploy the old versions, and which may be like as good as a couple of minutes ago. Because as we're talking about containerization, if you say that latency is pretty low and it's a Microsoft service architecture, that means database is pretty lean. So reversioning or rollback becomes really fast. And of course, continuous monitoring. That means, as I'm just not a big fan of drifting, so I always talk about, like, say, inventory is drifting, always talking about transactions are drifting, sources are drifting. So, how do we really monitor it every day? And that's where AI and ML methodology comes in, right? Hey, can we manage the drifts? Can we find out the different kind of alerts? Can we do the automation trailers? Can we do the say business tracking? Say I do have the spreadsheet or something came out on the floor. Can I use that one? So that will truly help out all this stuff. This MLOps architecture for production is again a suggestion. It may not really. We are still not there, so it will take some more time. So deployment strategies that reduce the risk. So there are like say I would say three or four different types of there. We should be doing shadow mode. We should be doing Canary deployment, A/B testing, full rollouts. Again, if you talk about say shadow modes means you can just do the predictions alongside the existing system with no operational impact to the compare with current practices. Basically, you run your predictions that hey this existing system and this new systems, I'll just say run the current system in the side, and then I'll just deploy the ML methodology new system on the side, and then say, can I just try to be see run in parallel and see can I make it closer? Can I do the canary management instead of doing the full one? That means and we do a small production, small percentage, like as agile kind of methodology where we do this in chunks rather than doing the full. And of course, we can compare out the still in the parallel for A/B testing. While doing the testing, still run the both the transaction and both the system in parallel, but in the test mode. And let's try to be compare out the both the systems. And of course, there is the waterfall, traditional waterfall methodology of full rollouts instead of doing everything, we just migrate everything. Last one is pretty risky, but I will say that generally I will be really a big supporter of the shadow methodology or set shadow model Canary deployment. Testing is still, I will say it's there, but it may not be as much as possible. Rep detection and retraining. So once we define out the new methodologies, our work doesn't really end here. Say all these models will be really going to be degrading, right? They will be running out for a time and time. There will be more scenarios will come up. Humans becomes intelligent, systems become intelligent, and then data will start acting again. So if you've seen our life in the industry from last 20 years, and I'm seeing our every new tools comes up and say, oh, this is the best, and after a couple of years, oh, it is not working. So we always, it doesn't mean that tool has changed. It means that new scenarios have been added and people have been detected. People have been intelligent, and that's where it's come up. So that's where it's really important that hey, we our models keeps on getting retrained and it keeps on trying. That's a kind of another one really, edge versus cloud distributed machine learning architecture. So if you talk about the edge inferences, can we do the time critical operations like the AGV navigation, real time routing, and collision avoidance? Again, this is say ultra. This architecture will be really going on the very ultra latency because of the lightweight architecture. And but it will be, of course, as soon as you go on the very low latency and lightweight architecture, that means you will be sacrificing the speed or sacrificing the accuracy. Sorry, speed will be extremely fast, but it will be really sacrificing the accuracy. And compared with cloud inference, which will be a lot more exact, but it will be really speed will be sorry, accuracy will be really not be compromised, but speed will be really compromised. Cloud inference is more of say current static databases, but as will be a lot more like an ML model kind of thing. So I will be really say that it has to be chosen between one or the other one. If we talk about like a medical industry, like I will choose the cloud one, but if you're like say talking about like say production one for something really making out like for example I do have my industry makes out the conveyor belts. So we may be going out in there. And of course there is a third one is like you can do a hybrid of both of them. So you can say, okay, something I will do in the time critical operation, I will do in the edge, and which are like say really quality kind of operations needed out, and maybe using all the cloud inferences. So most of them, I was just out again. This is a theoretical. We are still really researching out how do we really use this one more and more. Production machine learning application in action. So wow, that's like three different actions we talk about. This is a very interesting topic. Predictive maintenance, demand forecasting, inventory optimization, intelligent picking and routing. So I'm just really excited about talking about these three things. If you ask me about demand forecasting, inventory optimization has been there in the industry. It's not new. If somebody tells me that hey, AI is new in this world, no, this is not new. All these algorithms already exist in forecasting and optimization for like almost more than 10 years. Intelligent picking and routings, that's again our industry is really working really hard. So my industry, for example, is experts in the intelligent picking and routings. So we do have say robo pelletizer. What that does is it automatically finds the routes and automatically find out most efficient routes. So what that means that we optimize our conveyor belts to the factories. So all you do is you on the dock door you just put the parts and it automatically route it to correct lane and correct operations. Now predictive maintenance is the one which is really getting more and more popular, and that means all these parameters and sensors are still doing in manuals in the industry, but they are getting out a lot more. That's where the AI is really helping out, as machine learning models are really helping out, and those are actually monitoring the parameters, giving us the signals, and then we'll say, okay, do we need to adjust these parameters? Now, still it is not doing the automation, but this is again, I will say, the doing anomaly detection and which is taking the decisions really fast. Next one is responsible AI. So AI is really growing really fast. So we as a human being needs to be really responsible. Basically, we need to be fair. We need to be making design such a model that they can be explainable, and we need to build trust. So a lot of models formulas are really extremely complex. They are still not easy for the simple human behaviors to be understanding of. So that's why I say we need to be reducing all the so all the models should be really fair so that you put up say they shouldn't be we'll say equally it's like a human behavior even it applies in the models too. Model explanatory again I set out they need to be really simple. Still, current models, what we do have it, the operation teams are, for the operation team, it's really difficult to understand. I was just like working on like a safety stock formula. And when I developed my formula, it was really complex. And then finally, I just tried to explain operation team, I was struggled out. So what I end up doing is simplify the formula in such a way that an Excel will complete it easily so that operation could understand it. As soon as I did the same formula, rewrite in such a methodology, breaking down formulas, even if there's 5 steps, operations could understand it really well. So that's where all these models are still really large formulas needs to make sure that how do we really operation understand it. Like work on the planning of industry, methodology, planning engines are still difficult to understand, but again, it's going there. And of course, regression validation, that means we need to be really testing really well. We need to be doing a lot more shadow, a lot more A/B testing, a lot more Canary deployments instead of doing the full deployment. Full deployments means you will be it is a recipe for failure that's going on the. That's why I say that, like in terms of the IT product management, we talk about say waterfall methodology almost getting over, a lot more agile, a lot more people say, hey, I need day one, I want to see the system. They don't really care, say, what will be the system down the line, but they want to see day one, every day. Now, as I say about the SWM means you do have the ultra low model. Basically, it's a lot more speed is really fast. Latency is really actually, our latency is pretty low. So three things on that one. We do should be doing the quantization. We do should be looking at the pruning parameters. We should be looking at the knowledge distillation so that anyone can really those whatever we do the whatever models we use it out so their parameters are really accurate and production can understand it. So all these one are basically really good in terms of theory as well as in terms of the practically when we start doing our the edge deployment only for critical operations, it makes our life so much easier and of course the it will be a lot more faster decisions. Emerging trends reshaping warehouse ML. That's exciting as well. So if you see about say first one is auto machine learning and automatic feature engineering, that means all the operation teams are really looking for the rapid deployment cycles. They don't care about say gone are the days where the system where the businesses say that hey you do have 12 months, 18 months for deployment. Now they're asking like 2 months, 3 months, weeks. Even in some cases they're asking for days. Multimodal learning and sensor fusions instead of the having the one model, can we use the multiple models together? Can we compare the data and which model is better? Can we have the multiple type of sensors? Instead of the having the one type of sensor, can we have the like say RFID sensors and IoT sensors or environment sensors so that we can compare out say different kind of the models together and then we can have the better operational understanding and then of course we can have the anomaly detection and so that we can apply our time series algorithms to find the missing data. 5G enabled real time intelligence. So 5G is really another one shaping the world like anything. So now we don't need our like say a lot more Wi-Fi, internet stuff that everywhere there is a 5G available, and that means you don't need to be doing our like vast, massive networking investments. So we can use our the latency becomes really low and then of course the network slicing and for the machine learning workloads enables automation, autonomous vehicle coordination. That means your databases are a lot more getting out of the autonomous. So that means if not talking about milliseconds, we are talking about some milliseconds or really go even further than that. So decisions are really getting faster with this one as well because data is getting real times. So it's not like we are talking about data like say, a few hours ago, batch processing, all those stuffs are not really there. Sustainable and machine learning and green computing. Of course, we need to make sure that whatever we do, models, they are energy efficient, all the carbon awareness training skills are there, hardwares are really optimized, and that's where say we're talking about the edge computing is really getting shaping the world where you do the models are pretty lightweight. That means we don't need a lot of equipment, a lot of resources are needed out. And then we should have that like a lot more like workload manager. So assuming that say just take out the example one of the biggest company where I was really looking at it, the e-commerce platform was having 20,000 servers. And 20,000 servers means who does that? So what that means that they do have 20,000 servers, but all are really, a lot of them are the backup servers to make sure that everything is optimized. But if all those 20,000 were really low capacity, low pretty much in terms of the schedules and everything, they are really optimized. Excuse me. Lessons from the field. What separates winners from the failed project? So, failed project means if you're talking about, again, I'm saying, or say, full deployment, we should be definitely avoiding out. Do it in the slice and pieces. We should be doing instead of doing our full deployment, do it as a kind of methodology, which means incremental deployments. We should be doing our lot more cross-functional integration. That means we should be looking at the lot more teams together. So instead of doing one team doing all the work, all the teams should be working together, finding out what works best. And then, of course, the upfront we need to do the machine learning operation investment. Otherwise, what will happen that if you don't do machine learning operation investment, you will be at a recipe for failure, basically. Main idea on that one is the production, engineering, testing, everything can be automated. Otherwise, what will happen there is that you will be taking the people out of the floor and then trying to be do something, and then people will be not be able to testing out. Pattern should be avoiding out big banks, of course, big banks of full deployment should be avoided out. We shouldn't be doing the silo teams. We shouldn't be not doing only theoretical algorithms. We should be away from the without any monitoring. Monitoring is must. I will say reactive approach to the issues. I will be not a big fan of reactive, but I will say reactive as well as proactive, both of them. I may have put out the proactive as well in this one. From insights to the implementations, so if you talk about like say still production machine learning is not same as academic and machine learnings. Academic is a lot more theoretical, production is a lot more practical. Production doesn't need a lot more big formulas. They are really looking at the simple where the people can understand it. Start small, scale smart, basically same repeating out the agile methodology. Should be looking at people plus process plus technology. All three things to be prepared together. And of course, architecture matters. It's not a no-brainer. Next steps, if you talk about it, assess your current methods, current machine learning maturity level. And of course, so pilot is really, they always go with 80-20 rule. So 80-20 rule means high value use case should be piloted first. Then investing in machine learning operation infrastructure early. And of course, cross-functional teams are a lot more people are doing it, and deployment strategies should be really well made with the toll gates or safety gates. So that's the takeaways from here. And thank you so much, everyone. That's all from my side today. And bye bye.